This is lecture 16 of basic calculus 1. So, as you recall, in the last lecture we had given the rules of differentiation and then applied that to some of the problems. So, today's lecture will be simply problem based. Basing on again those notions, we will solve some more problems. So, let us go to the first problem or exercise 1, which says that we find the tangents to the curve y equal to 4x divided by x square plus 1 at the origin and also at 1, 2. So, there are 2 points where we have to find the tangent. This particular curve is called Newton's serpentine due to its graph. So, y equal to 4x divided by x square plus 1, that is our function. We want tangents at the origin and at 1, 2 points. So, first we differentiate and evaluate at 0 to get their slope. Similarly, at x equal to 1 to get the slope, and then use the straight line formula that it passes through 1, 2 and having this and this slope. Okay. So, for differentiation y equal to 4x divided by x square plus 1, it is in the form f of x divided by g of x. So, its derivative will be g x into f prime x minus f x into g prime x. So, this is g x is x square plus 1, it is x square plus 1 into derivative of 4x, which is 4, minus 4x times derivative of x square plus 1, which is 2x, that is on the numerator, and in the denominator we will have g x whole squared, which is x square plus 1 squared. Then we simplify. So, this gives minus 8x square and this is 4x square. So, minus 4x square and the constant is 4. So, 4 minus 4x square divided by x square plus 1 whole square. So, when you evaluate this at the origin, this x will be equal to 0. So, there once you substitute x equal to 0, in the numerator we get 4, denominator becomes 1. So, y prime 0 equal to 4. Similarly, when you take x equal to 1, because we want at the point 1, 2 also. So, y prime at 1, substitute x square equal to 1, that gives you 0. So, these are the slopes. So, when you say y prime equal to 0, that means it is parallel to the x axis at 1, 2, and here the slope is 4 at the origin. So, the equation of the tangent at the origin will be y equal to 4 times x, that is it, and the tangent at the point 1, 2 is y minus y 1, which is 2, equal to slope is 0, x minus x 1, which is 1. So, you simplify, that gives y equal to 2. It should be parallel to the x axis. So, that is how we will be proceeding. This is an easier one where differentiation is easy. We will take the next problem. So, in this problem we are given that f is a function where f of 2 equal to 8. So, we assume that it is defined everywhere unless there is some problem. Next, there is another function which is g. It is given that g of 2 is equal to minus 3, and also we are given their derivatives, say f prime at 2, again both at 2 we are taking. So, f prime at 2 equal to 1 divided by 3 and g prime at 2 equal to minus 3. So, we are required to find the value of the derivative square root of f square plus g square at x equal to 2. So, all that we have to do is differentiate this and express that in terms of f prime, g prime, f, g if possible, because everything is at 2 only, then that should give us the answer. Okay. So, first we differentiate derivative of square root of s square plus g square, we have to use the composition rule. So, it is square root of something. So, that something if you take as say z, then it will be d of square root of z divided by dz. So, we go on writing with our experience that d square root f square plus g square with respect to f square plus g square, and then it will be multiplied by d of f square plus g square with respect to x, and all these things have to be evaluated at 2 only. So, let us find out. So, this first one is d square root z by dz, which is 1 divided by 2 square root of z. It is z to the power half. So, it is half into z to the power minus half. So, minus half brings z to the denominator. So, it is 1 divided by 2 square root of z, which is 1 divided by 2 square root of f square plus g square. Then we differentiate f square plus g square with respect to dx. Again df square with respect to x we want. So, first we differentiate with respect to f and then f with respect to x. Similarly, g will be d of g square with respect to g and dg by dx, and they will be added together with our plus rule. So, that is how it will look now. Now, d of f square with respect to f would give us 2f, and then df by dx is f prime anyway. Similarly, dg squared by dg is 2g times g prime. Now, we do not know how to evaluate this at any point, but we are given that at 2. Our data says f g, g, f at 2, g at 2, f prime at 2 and g prime at 2. And of course, we want derivative of square root of f square plus g square at 2. So, we evaluate both the sides at 2, then we would get the answer at 2 equal to 1 divided by 2 square root of f square evaluated at 2, g square evaluated at 2 and everything like 2 f 2, f prime 2 to g 2, g prime 2. Then we substitute the values and simplify to get the answer, and that should come out to be minus 5 divided by 3 square root of 710. You should verify this. Okay, so that is how we will be proceeding by using the chain rule. Let us go to next problem, where we are given dy by dx. To find out dy by dx, given that y is equal to a function of x which is 1 plus tan fourth of x by 12 whole cubed. So, again as you see, it is a composition of many functions. So, once you differentiate, we have to differentiate the inside first, like z cubed with respect to z, then dz with respect to x, that will be 1 plus tan fourth x by 12. So, we proceed slowly. Suppose we put z cubed, z as 1 plus tan fourth x by 12. So, we proceed the other way. Let us say t equal to x divided by 12 and u equal to tan t. So, that means it is tan of x by 12 and w equal to u fourth. So, that means tan fourth of x by 12 and z equal to 1 plus w, that means the inside expression 1 plus tan fourth x by 12 and y equal to z cubed. So, that is how it will look now. If you read from the left side, y is z cubed, z is 1 plus w, w is u fourth, u is tan t, t equal to x by 12. So, our formula will be dy by dx equal to dy by dz, dz by dw, dw by du, du by dt, dt by dx. Again, it is an application of the composition rule. So, slowly if we proceed, we say that dy by dz, which is y is z cubed. So, that gives 3z square, and dz by dw. So, it is 1 plus w, that gives 1 is 0, w gives 1, and then dw by du, which is w is u fourth. So, it is 4u cubed. Next du by dt, u is tan t. So, it is secant square t, and dt by dx, t is x by 12. So, dt by dx is 1 by 12. That is how it looks. Then you substitute their values to get the answer, which will be z is 1 plus tan fourth x by 12. So, it will be 3, it will be 3 and this 4 cancels with 12. So, we have cancelled it. What remains is z square u cubed secant square t. So, z square is 1 plus tan fourth x by 12 square, u cubed is tan cubed of x by 12 and secant square t is secant square x by 12. Or directly you could have done, if with a slight experience, instead of substituting all this, we just write d of the total equal to d of that cubed divided by that one, which is it was our z. Then dz by dw would look like d of 1 plus tan fourth x by 12 divided by r over d tan x by 12. Then d tan x by 12 over d x 12 and dx by 12 over dx. Then immediately you get it is tan fourth. So, it is 3 times tan square, and this gives us 1 plus tan fourth, it is like 1 plus z fourth by z. So, that gives 4 tan cube z. 4 tan cubed x by 12, and then tan x by 12 divided by x 12 by 12, that is secant square x by 12, dx by 12 by dx is x by 12. As earlier, we get the same answer, which we know how to obtain. Okay, so this is how we will be proceeding. Sometimes the direct method will be easier to follow, but if there is a confusion, it is better to substitute and see how it goes slowly. Now, we go to the next problem. So, this is the fourth one. We are required to find the derivative of the function y equal to f of x, where x and y, f of x is not given as an explicit expression, but x and y are given parametrically. So, there are some problems under this. We take the first problem, which is A. The parametric equation for x and y is given as x equal to a cosine t, y equal to a sin t for t varying between 0 to pi. So, what is this really? X equal to a cosine t, y equal to a sin t. So, it is a circular arc where a is the radius. It is really upper semicircle cos t sin t, because t varies from 0 to pi, t varies. So, it is the upper semicircle. Y equal to x square plus y square equal to a square, or we write y equal to square root of a square minus x square. So, we have now two ways open. We can directly take y equal to square root of a square minus x square, differentiate this, or we may go to parametric differentiation, find dx by dt, dy by dt, and then take suitable multiplication or division to find dy by dx. Okay. So, let us do the parametric way. Now, dy by dx is dy by dt whole divided by dt by dx by dt. So, the first one gives a cosine t divided by a cosine t differentiation, that gives minus a sin t. So, a and a cancels, we have minus sign, and or we can directly say a cosine t y equal to a sin t. So, it is just minus x divided by y, or if you do directly also, you can get the same answer, y equal to square root of a square minus x square. So, dy by dx will be the square root with respect to that factor first. So, that will give you 1 divided by 2 square root a square minus x square times a square minus x square with respect to x. So, that would give minus 2x. So, these 2 cancels, and you get minus x divided by square root of a square minus x square, which is same as minus x divided by y. Okay. So, we go to second problem under this fourth problem, that x and y are given parametrically and we want to find dy by dx. So, here the equations are x equal to a cosine t, y equal to b sin t, and where t varies from 0 to pi. So, this is an ellipse with the upper part of the ellipse, okay, with a is this semi minor axis and b is major axis and b is semi minor axis. So, that is how it looks like. Again also you have two options, whether to do parametrically or directly you can do. So, let us do one of them, say parameter, we will use parametric differentiation. Now, here dy by dx is dy by dt divided by dx by dt as earlier. Now, y is b sin t. So, its derivative with respect to t is b cosine t, and x is a cosine t. So, its derivative is minus a sin t. Okay. But we have x equal to a cosine t, y equal to b sin t. So, we need to express in that form. So, you multiply one b by a, that gives b square by a square into a divided by b. So, they cancel, one b cancels here, one a cancels here as earlier, minus sign remains, we have cos t sin t. So, now a cosine t, that gives you x and b sin t gives you y. So, our answer is b square x divided by a square y. Of course, you can do also y equal to f x directly as earlier for the case A, you should get the same answer. We have the third problem under this, where our parametric equations are x equal to a times t minus sin t, y equal to a times 1 minus cos t, where again t varies from 0 to 2 pi. So, this is called a cycloid. Now, we proceed again similarly and compute dy by dx, which is d of x, this is your x over dt, divided by dy over dt, which is we want dy by dx. So, it should be d, there is some problem here. So, it should be dy by dx, not dx by dy. We are computing dy by dx. So, these ones should be d of a into 1 minus cosine t over dt divided by dx by dt or dA of t minus sin t over dt. So, that would give a minus cosine t. So, this is a remains and minus cos t, 1 is 0, minus cos t gives you sin t, a sin t divided by, this is a remains and t is 1, minus sin t gives cos t in the differentiation. So, it is a sin t divided by a into 1 minus cos t, that is how it looks. So, it is easier to keep as it is, because a just cancels, you get sin t divided by 1 minus cosine t. So, what we calculated here was given, that is dx by dy, not dy by dx. So, if you write dx by, if you want to compute dx by dy, that will be equal to this on the top one, whichever is given. Okay. So, that is how we will be proceeding, and then this is the sin t divided by 1 minus cos t. Okay. So, let us go to next one. So, fourth one says that x is given as a cosine cubed t and y equal to a sin cubed t. Again t varies from 0 to 2 pi, this is called an asteroid. If you eliminate t from here, you would get the equation in this form, x to the power 2 by 3 plus y to the power 2 by 3 equal to a to the power 2 by 3. To verify, you can just substitute. So, that gives you x is a cosine cubed t. So, that to the power 1 by 3 gives a to the power 1 by 3 into cos t. So, it is a to the power 2 by 3 cos square t. Next one will be a to the power 2 by 3 sin square t. So, that would simplify to a to the power 2 by 3. That is how you eliminate t. Okay. So, you want to find out what is dy by dx. Again, that is y. So, dy is a sin cubed t by dt into divided by dx by dt, x is a cosine cubed t. So, that is how it is. Then you differentiate, sin cubed t differentiation will be sin cubed t with respect to sin t multiplied by sin t with respect to t. A remains as it is. Sin cubed t with respect to sin t gives you 3 sin square t, and sin t with respect to t gives you cos t. And in the denominator you have a cosine cube t. So, again use composition formula. So, a remains as it is, d cosine cube t with respect to cosine t, that gives you cosine square t into 3, and then d cosine t with respect to t, that gives you minus sin t. So, the minus sign here. Then 3a cancels and sin t cos t cancels. So, you get minus sin t by cot t, which you can express also in terms of y by x. Now, this is a nice one to verify directly. If you use implicit differentiation, differentiate this equation directly, you should also get the answer that you can try. Okay. So, we go to next problem. Here we are asked to find the derivative of square root of mod x. So, as we know, if you take mod x, then its derivative you can find, of course, where when x is less than 0, its derivative is minus 1 at every point x less than 0, and when x is bigger than 0, its derivative is 1 for x bigger than 0, and at 0 it is not differentiable. But we are asked to find the derivative of f x, square root of that, square root of mod x. Mod is of course non-negative, so square root is well defined for any x. So, its domain is the whole of real numbers. Then we must consider our experience says we must consider 3 cases separately, when x is less than 0, when x is equal to 0 and when x is bigger than 0. Okay. So, let us take the seemingly easier, which x is bigger than 0. Then you have square root of mod x as square root of x, because mod x equal to x in that case. And we find its derivative directly. So, f prime is 1 divided by 2 square root of x, x to the power half. So, that gives you half times x to the power minus half, which is 1 divided by 2 square root of x. So, for x greater than 0, this is the derivative. Now, when x is less than 0, mod x becomes minus x. So, square root of mod x is square root of minus x, x is smaller than 0. So, it is non-negative, it is really positive minus x. So, it is square root. So, that is meaningful. Now, to take the differentiation, how do we proceed? We differentiate with respect to x, not minus x. So, it will be minus x to the power half, its differentiation, it will be half and minus x to the power minus half, and then, so minus x to the power minus half we are not going to write in terms of x, it is minus x is positive. So, it will be just as it is, it will be kept, and then minus x d of minus x with respect to x, that gives you minus 1. So, you get minus 1 divided by 2 square root of minus x, that is what it is. Okay. X is negative. So, square root of minus x is meaningful. Now, at x equal to 0, what happens? So, for f prime 0, that is when x equal to 0, what will be the derivative? These formulas will not give anything. So, we go back to our definition. By definition, it is f of h 0 plus h minus f of 0 divided by h. So, now what is f of h? H can be positive or negative. When h is positive, so f of h is square root of h. So, there is no 1 here, right. So, it is square root of h, but we are computing divide by h. So, when you take divide by h, that gives 1 divided by square root of h. So, that is fine. Next, when h is less than 0, f of h is square root of minus h. So, square root of minus h divided by h, that gives you, it is square root of minus h divided by h. So, this h will be writing minus and another minus h. Now, minus h is positive. So, square root of minus h cancels, you would get square root of minus h here. So, it is minus h square root and there is a negative sign. So, we take it to the top, we write minus 1 divided by square root of minus h, that is correct, for h is less than 0. This is how this ratio is evaluated. To find the derivative, we have to really compute the limit of this as h goes to 0. So, when h is greater than 0, when h is less than 0, we have to take the right hand and left side limits. And what will be the limit? When h is greater than 0, that is h goes to 0 plus its limit, it is 1 divided by square root of h, that becomes infinity. And when h is less than 0, it is minus square root of. So, it is 1 divided by square root of minus h gives infinity, there is a negative sign. So, that gives you minus infinity. This is how the limit looks like. Therefore, f prime 0 does not exist, that is the function f x equal to square root of mod x is not differentiable at x equal to 0. Okay. Even we cannot redefine any way we like, because they are blowing up, they become infinity on one side, minus infinity on the other side. So, that is why we said derivative of f x equal to f x at x equal to 0 does not exist. Okay.